Okay, today we're going to be doing a little bit of review of what we did yesterday. And the main thing we did yesterday was simplifying rational expressions. This isn't an equation because it doesn't say like equals 12. That would be an equation. It's an expression, meaning there's no equal sign, and you're just supposed to simplify it. First step, start down here, and I've said before, if you can factor it, you should. And that 15 can be factored into what? 5 times 3, and then see how the 5's cancel? Now your life's just a little bit easier. Smaller numbers. Next, I have an a and a b. That's a b over 1. I've said before that fractions play nice with other fractions, so you got to make that b into a fraction. Now it's easy to see. It's ab over 3. I'm rewriting. How many of you got it that far? Good, then I bet you got the last step too, which is change this to times instead of divide, and then you flip this over, and the 3 is on top now over AB. Final answer, 6 over 7AB. Raise your hand if you had that one right. Good, you learned something the other day then. All right, so I'm going to pause for a second while we pull up today. And we have an athlete theme for this time. Recognize him? That's Bruce Jenner. Hear about any news about Bruce lately? You mean Caitlin? Sorry, Caitlin. So Bruce Jenner used to be a Olympian, and he was really, really, really good. Made it on the cover of the Wheaties box. So looks different now. All right. 3 times 12 is 36 equals 4x. Now I'm dividing by 4. And I got 9 equals x. Raise your hand if you got the same thing. Okay, good. On to the next one. You can multiply across the top, multiply across the bottom. And there is no canceling that can be done that I can see. Can you see any canceling? Okay, then it's okay to just proceed and multiply, and you get 3/8. Any question on that one? All right. That is a good question, and it says, where can you cross multiply? Which one do you cross multiply on? The kind that has an equals on it. If I were to cross multiply this, it would give me 4 equals 6, and that's not true. All right? 4 doesn't equal 6. So can't cross multiply on that kind. And that is like an important distinction. When you're multiplying across, that's different than cross multiplying. Cross multiplying you do when you have like this with an equal sign. Then you multiply across it. 4x equals 36. Okay, moving on. Who's our athlete this time? Recognize him? Peyton Manning. All right. That didn't take you long. All right. Do some cross multiplying and some multiplying across. Let's try to remember which one's which. And remember, if you can factor it, you should. Because then things will cancel nicely. I'll pause for a second. Yeah, you can do the factoring at the end, no problem. It is a little faster in a problem like this if you factor it before you multiply it, just because you'll be having to factor 48, which is not very fun to factor, as opposed to factoring a 12, which is pretty easy to factor. So your choice, but it's probably faster to do it sooner rather than later. I'll pause while you try that one. Okay, here's how I would have done this. Just would have checked quick to see if there was a 3 in the 14 so that I could do some cross-canceling there. But that wouldn't have actually worked out too well. Because I'm supposed to cross-multiply here. 2x equals 42. Now I can divide by 2. And x equals 42 over 2. I have this sneaky suspicion that 2 goes into 42. And so, does it? 2 times what? I think it's 21. Okay, hands cancel. Answer's 21. Raise your hand if you had 21. Okay, good. On to the next one. Can factor it? You should. It is 8 factors into 4 times 2. I'm choosing that on purpose because I see this 4 right there. 8 does also change into 8 times 1, which really wouldn't help me very much. So or 2 times 2 times 2, which also wouldn't help me very much. So canceling the 4, and then how about this 12? 3 times 4, and you write a 3 times 4, and why do I do that? So that the 3's will cancel. Final answer is, oh, wait a minute, I could factor the 4. 4 turns into what times what? 2 times 2, and then the 2's cancel, and then nothing on top, so it's 0 over 2 equals 0, right? No. What should be on top? A 1, because when all those things were canceling, they were leaving little 1's behind. All right, so the final answer is 1 over 2, and that's your answer, 1/2. All right, awesome. On to the next one. I don't think we need to practice this more. We'll just check which athlete we have here. You know this guy? Phelps. Very good. Okay, so is this equal? Is it less than? Is it greater than? Well, it would help if they had the same denominator. Once they're the same denominator, it will be easy to tell. Now, if we had a calculator, I'd just get the decimal for both of them. It'd be super easy. Okay? Now, it does say related to cross multiplication. All right. What does that mean? Watch. What's that? And what's that? 28. Okay? But the problem is that doesn't just, all it tells you is they're not equal, and therefore we don't use the equal sign. But how do you know whether it's less than or greater than? Yes, that's true. But couldn't I have said 28 equals 33? But my point is that I could have written this, and then you can't tell from this which way I should put the sign. I agree that 33 is greater than, but does that mean these two are greater than? Or is, in this case, it's a less than, so are these two, is it a less than? You know which one it is? All right, I'll tell you which one it is. It's, oh, sorry. Let's say that we had 7 pieces of pie. You get to have 3 out of those 7. Or we had 11 pieces of pie, but you got to have an extra piece. 4 out of the 11. Which one's more? All right, so it's a less than sign. Now, to me, that other method of cross multiplying only just begs the question of then which one do you have to cross multiply first? Okay, and 7 times 4 is 28, and 3 times 11 is 33. And if you can remember that you always do those two first, and they go in there and it's a less than sign, cool. But I hate having to like a 50-50 chance of remembering which way it goes. So, what's a better way? Yes? Get a common denominator. All right. So, what is a good denominator for these guys? 77. So you times this by what? And that's the same on top, and times this by what? 7 is the same on top. So this is going to be 28 compared to 33. And now can you see? So if you make them a common denominator, I think it's a lot easier to make sure you know. Otherwise, you're just going to be guessing. Should I say 33 equals 28 or 28 equals 33? Because if you do it backwards, you get the backwards answer. If you make them common denominators, 28 77ths compared to 33 77ths, it's really obvious that this side's bigger, and the alligator always eats the bigger meal. But it doesn't eat it right away. Alligators like to eat things that have been rotten for a while. So typically, when they grab you and they drag you down into the depths of the river, they won't eat you right away. They're going to stuff you underneath a log down there and leave you there for a few days until you're ripe. You don't even have alligators in Minnesota. All right. Try this one. I'll pause for a second. Let me try that. Okay. 55, 70, this way will work, but you got to go like, did I do it the right way? So I should put the less than in this way? Yep. Yep. If you start with top left, that will work. Or you can change them both into 77ths, and then you can be for sure about it. 55, 70. So it is a less than sign. Raise your hand if you had that one right. Okay, good. And who's our athlete this time? Anybody know that guy? I was going to say, I thought it was Tony Hawk. All right. Well, John White has a board, so at least you got that going. Okay, but all right. This one, if you're going to compare them, I would not multiply both sides by something. You still need a common denominator, but only the right side needs to get fixed. Times it by what? Let me ask you this. Would that make the denominators the same? Once the denominators are the same, it's pretty easy. 100 equals 100. What's that mean? They're equal. Oh, you remember the whole if you can factor it, you should thing? Yeah, this one would factor. That's the way I'm going to say it. This would factor to 10 times 10. This would factor to 10 times 100. And then the 10s cancel, so it's 10 over 100, which is 1 over 10. Or, I'd even been smarter if I'd have done this. 10 times 10 times 10. Then I could cancel 2 10s. And then it would be 1 out of 10. Okay. Is this true? Well, obviously 1 plus 1 equals 2, and therefore it must be true, right? No. That part is true, but this other part then is the question, are these two really equal to each other? Can't you just cancel these x's and make them into 1s? You can't cancel. One of my favorite topics. Can or can't you cancel? You can't cancel these. Because why? Because it's addition. If this had been a multiply right there, if this was a time sign, then yeah, it would have totally been okay to cancel them. But that was not a time sign, and therefore you cannot do that. And who's our athlete now? False. That is Mary Lou Retton. If you want to see something super inspirational, notice how she's holding up her left leg? You recognize that? Is that the way they normally stand when they're like doing their like proud little like I'm done, I put my hands up and I'm posing at the end? No, it's because her ankle is shattered. And she did her routine with that, with like and she needed that last vault to have the U.S. team win. She needed a good score, and she had to do it with a messed up ankle, and she did it. That takes guts. Remind me, I'll show you that video clip. It's amazing. All right. No, not right now. Okay. Can you cancel or not? Careful, careful. Or can you? What is x plus x? And doesn't that make it into a little times problem instead of being an adding problem? People forget all the time that that's 2x. Now can you cancel them? Oh, apparently you can. Cancel, cancel, the answer's 2. All right. For this little athlete theme, anybody know that one? Lindsey Vonn, famous skier. From Minnesota, cool. All right, this one. What's my little saying about factoring? If you can factor, you should. This one you can factor. And therefore you should. And then you'll be able to cancel some stuff. Sir? I haven't. like of them pulling a bunch of fluid off her knee. Oh, nice. My brother had that fluid on the knee thing. He was actually in training to be a Navy SEAL. He was in the Navy, and he was in SEAL training, and he still regrets, although in the end it worked out okay and everything, but he was going to be a Navy SEAL, which is like the toughest thing, and he was in the training process for it, and he and some of the guys were just goofing around in their free time, and he was chasing a guy around a table, and he banged his knee into the corner of the table, and he got water on the knee, and the doctor said, nope, you're out, done. But now you're already in the Navy. You can't just say, well, I'd like to go home now, because you're in the Navy. You signed up for 4 years. So he went from Navy SEAL, where she would have been like swimming in underneath submarines and like putting on depth charges and swimming away and, you know, super exciting. They gave him 2 choices. You can be a cook or you can be a medic. And since medics have to deal with blood and he like passes out at the sight of blood, he only had 1 choice really. So he became a cook. So he went from Navy SEAL to cook in like the course of a week. Can you imagine how depressing that would be? Anyway, so he was a cook for 4 years. So the best thing he could do, given that, was try to get to the hardest assignment possible. So the hardest assignment to get in the Navy is to get onto a submarine, because it takes the most training to be on the sub. And so he went for it, and he got trained. He had to learn, memorize all these systems and pass this test. And you have to pass a psych test to go on a sub, because they don't want you going crackers out in the middle of underneath the water. And sometimes you're inside a submarine, which is underwater, and then underneath a giant ice shelf that they can't even come out from under. Like they can't break through. So like if their sub has problems, they're done, because there's a giant sheet of ice over the top of you, and you can't go up and get air. Think about that. So you have to be able to handle that. He said some mornings you'd wake up and it would be just icy cold, like everything was freezing cold, and they wouldn't tell them where they were. So he didn't know where they were, but he knew it was someplace really cold, and then he'd find out later, oh yeah, we were underneath the Arctic ice shelf or whatever. So, because they were afraid that if they were a spy, they'd be able to relay information about exactly where they were, and the Russians always wanted to know where were our subs. They wanted to track them as best they could. So there's something called, back then it was called loose lips sink ships. Have you heard that before? And if a guy would say, hey, our boat's going to be coming into the harbor over here, then the bad guys would know, okay, well, we got a ship that's going to be going through this area, so we just have to send a couple of subs over there and we can sink it. So loose lips sink ships. All right, I hope you noticed there was an H in both of these and you took it out. And that's the only H that could get canceled, because now that's part of a multiply problem, and then it can be canceled. H to the third plus 2 is what you got left. You know that guy? Lots of Super Bowl rings. Joe Montana. Quarterback for 49ers. All right. This one. Say my favorite saying. Can ya? Can't factor the top. Can you factor the bottom? That's the question. Oh, but you can. Sharpen up your pencils, even if they're virtual, and factor that puppy. And once you factor it, something will cancel, and then if you can factor it, you should. So if you get it factored, then stuff cancels. Meanwhile, while you're doing that, here's a picture. You know who those guys are?
Are they the volleyball ones? Yeah. Oh.
Misty Trainer and Carrie Lee Walsh Jennings. Somebody new Misty trainer? Oh, cool. Must be a volleyball player. No? You watched it? Okay, cool. So Misty trainer and Carrie Jennings. We got 4 names. Carrie Lee Walsh Jennings. But anyway. X and X. And how do I make a 12? A 3 and a 4 is probable. And since that's probably going to cancel, I'm going to throw in a negative. And then I'm going to say, oh, okay, what should I put here? Plus. Now I'm going to double check and see if it worked. First, x squared. Outside and inside makes positive x. Oh, that's the exact opposite of what I wanted. So flip the signs. If it's the exact opposite of what you want, change this to plus, make this a minus. And there, it factored. So that part is true, but nothing cancels. I know, you want stuff to cancel, but that's not always that they actually will. So that's a trap. Also a famous line from a movie. It's a trap. You got it. Very good. Okay. So you're going to assume that, oh, it's probably going to cancel, so I'll just make this x minus 3. And if you don't check it first, it'll be wrong because the outside and the inside don't actually make negative x. So I got to change this to plus and this to minus, and then just nothing cancels. Okay. This one. This is just plain old-fashioned add and subtract, but I don't think we need practice on that. This is, we practiced that the other day. This is the only one that's different. How do you add those together? Okay, you're right. Everybody multiply this by something, everybody multiply that by something, and you'll find the common denominator is 8x. See if you can do it. Multiply by something on both sides. Got the thunderstorm theme going today. Kind of enjoying that. It actually started because of vectors. And you probably noticed these things up here before we have the 3D thing because we do vectors in honors pre-calc. And the vector involved in lightning is lightning goes from one spot to another spot and it has a direction and a magnitude. Do you know that if you want to make the next big idea, I'll tell you what one of them would be that's not that complicated. I can make lightning strike something. It's not that hard. Build a really tall tower and let thunderstorms go over and it's going to hit it. Even like barns have to have these things on top of them, a special thing called a lightning rod, which allows the lightning to hit that and it'll be safe because that's grounded. If it hits something up there that isn't grounded, it just blows it apart. Okay, but if it's grounded, it's fine. Well, if you could just make it so that you could store the power that comes in a lightning bolt, there is so much power that comes in a lightning bolt that one lightning bolt could power Minneapolis for like an hour. All the power for all the people in the whole city from just one lightning bolt. So all you'd have to do, figure out a way to store the power that's in a lightning bolt in a battery system. If you could figure out that, it would be so easy to just install these lightning rods with battery power underneath them. Because the problem is it fries the batteries when you get that much power coming through. But if you can figure that out, you got $1 billion idea. I guarantee you, some big company, if you had the patent on that, would pay you $1 billion for it so they could start manufacturing them. Because you could put an end to power plants that have nasty, like, bad emissions and stuff, and you could solve so many of the planet's problems with pollution by just harnessing lightning. It's happening all the time. Like right now, there's lightning bolts striking somewhere. Like all the time. There's thousands a day. You just figure out how to harness that. And while you're at it, after you're done with that, maybe you could cure cancer too. It'd be kind of nice. Okay. Times by x times by x. Why did I do that? Because I knew the denominator is 8x, so I needed an x there. And if it's going to be 8x, then I'm going to say an 8 there and an 8 there. That way, it's 8 plus 5x all over 8x. And then some neophytes will cancel the 8s. They can't do that because why? That's part of an add problem. That's part of an add problem. It cannot be canceled. Okay, there you go. 8 plus 5x over 8x. Raise your hand if you had that one right. Okay, good. You got to be able to do that for our little test on this stuff. All right, now the least common denominator. That's basically all about what do we need to use for a denominator here. Do you agree that 2x is different than all that? But what do they have in common with each other? They both have what in them? A times by 2. They both have a times by 2. So we don't need to times everything by 2. It's already got a 2. What do we need to times this by, and what do we need to times that by, so that they will have a common denominator? I'm going to give you a hint. When it's all done, the common denominator will be 1, 2, and an x plus 1, and an x. That's the common denominator. If this is the common denominator, it's because I had this, and that were my 3 different pieces, and you got to put all 3 together to get your common denominator. Before it was simpler. It was like this. And now the denominator would have been what? X times y. But what if I have like a 5xy? Do you get how it needs to be all 3 things? 5 and x and y? So this one would need to be times by 5x, and this would be times by y. Then I have 5xy for both denominators. Same idea on this one. The thing I need a 2 and an x plus 1 and an x. Those are my 3 separate things. So all of them together is the common denominator. All right. Odds again. This time, be ready for the grading part of it tomorrow.
Yes.
I promise you we will be grading. So have her done. Odds on both. That's all I got for you for today.